Hi everyone, this is Koray Kinik, and I will be presenting my final project for this semester's class, Functional and Stream Programming for Big Data Systems. I will show you a small but scalable and fault-tolerant pipeline for streaming data processing. I created my own data synthetically. These are credit card transactions with user data and geolocations. In my collection tier, I have a Flume agent collecting these events and pushing them into a Kafka-Streams application. And Kafka is doing all the data aggregations and publishing the results into an Elasticsearch cluster. So let's go a little more details. I have a Python script that continuously generates events and dumps them into a log folder. And I have a Flume agent running on the host that monitors that folder. And I have a Docker compose with a Zookeeper container and a container for a Kafka cluster, which has an input and output topic. And I have Kafka-Streams application running in Java. I have an internal network and an external port to listen to the host, and the Flume is sending the raw logs to that port. And my Kafka-Streams application is receiving those raw events from the input topic, processes them, aggregates, filters, maps, and sends them to an output topic. And after the streams operation, we have the indexing. I have a Kafka API script that listens to that output topic and receives the data and indexes them to an Elasticsearch 3-node cluster. So let's make a demo now. We see three main components here: the data collection tier, stream processing tier, and we have indexing and visualization. The first one is running in PyCharm. We see that the Python script is creating those events and saving them to a log file. And the Flume agent is running to collect those logs and push them into the Docker containers. The second part of the pipeline runs in my IDE idea. The Java code is here. We see the Docker containers. One of them is for the Kafka topics, and the other one is for the K-Streams Java app. And this is how the Docker compose looks, and this is how the consumer streams Java app is looking like. So we have windowed operations for 10 minutes window. And the third part of this pipeline is the visualization. I have 3-node cluster for Elasticsearch, and the visualization is here. Each of these bubbles represent a financial transaction, and larger the bubble, larger the transaction. On the bottom, we see the total spending aggregated results of the 10-minute windows that the K-Streams is sending to this visualization. And when we refresh, we see the updated results of the 10 minutes windows. Thank you.